Hello friends, in my last video in hybridization, I explained you hybridization in the case of sp and the sp2. In sp hybridization means one orbit of the s and the one orbit of the p, they hybridized and formed the two orbitals of the same energy. Now today I will explain you sp3 hybridization. sp3 means 1s and 3 p orbitals. They hybridized to form the 4 sp3 hybrid orbitals of the equality energy, and they are at the 4 corners to form the regular tetrahedron, and the ratio of the s and the 3 orbital is 25% s character and the 75% of the p character. So this is the sp3 hybridization, in which 1s and 3p orbitals they hybridized to form the 4 equivalent hybridized orbitals. This can be explained by taking an example of the methane, that is CH4. Here if we see the configuration of the carbon, that is 1s2, 2s2, 2p, x, py, that is the 2 electrons in the p orbital. If we see 2 unpaired electrons in the p orbital, that is x and y, and we know that the carbon shows the 4 valency. So in excited state, 1 electron of the x is promoted to the p orbitals. Now 1s and the 3p they hybridized and form the 4 equivalent orbitals of the equality energy. Now if we see the structure, carbon 4 hybridized orbitals, they overlap with the hydrogen to form the sigma bond, and it gives a tetrahedral geometry. See, it gives a tetrahedral geometry. So the example of CH3, where the center carbon atom has the configuration of 2s and the 2p orbitals, and we know that the valency of the carbon is 4. So one of the electron from the 2s is promoted to the p orbital. Now 1s, 3p, they hybridized to form 4 orbitals of the equality energy, that is sp3, and it forms the tetrahedral geometry. Now this sp3 hybridization can be explained by taking more examples. For example, in the case of the ammonia molecule, that is NH3, here if we see the electronic configuration of the central atom nitrogen, that is 1s2, 2s2, 2px, 2py, and 2pz. In this case, if you see 3 unpaired electrons in the p orbital, and nitrogen shows the 3 valency, so there is no need of the promotion of any electron from s to the p. Now here 2s and 3p they hybridized, 2s and 3p they hybridized to form the 4 sp3 hybrid orbitals. of the equivalent energy. Now in this case, listen, 3 unpaired electrons, it means it will overlap with the 3 hydrogen atoms and one lone pair will be left. So the structure of the ammonia will be like that: nitrogen single atom and the 3 unpaired electrons, they overlap with the hydrogen atom to form the sigma bond. Now one lone pair is left. So we will say that the lone pair is apex and the base is 3 sigma bond, that is hydrogen bond with the nitrogen. Now here one point is very important. You know, repulsive force of the lone pair to the bonded pair is more than the force of atom pair to the bonded pair. So there is a distortion in the structure and the angle becomes between hydrogen is 107 degree. It's very important. That is the repulsive force of the lone pair. So we say the shape become, that is a pyramidal shape. Now we take one more example of the water molecule. Here the configuration of the single atom is 1s2, 2s2, 2px2, y and z. Now here if you see in the p orbital 2 unpaired electrons. 2 unpaired electrons, it means these 2 unpaired electrons, they overlap with the hydrogen atom. So 2s and the 2px, yz, these orbitals, they undergo hybridization to form the 4sp3 of equivalent energy. Now here in this structure, if you see 2 unpaired electrons, they form sigma bond with the hydrogen, and the 2 lone pair. Then you know force of repulsion of the lone pair between the bonded pair is more than the force of repulsion between the bonded pair. So again here the angle decreases to 104.5. That is the nitrogen hydrogen bond is 104.5, and this shape become like V shape or it is a angular shape. So these are the examples which I explained today for the sp3 hybridization. In my next video I will explain you some more examples of the hybridization. If you like my videos, please share and subscribe. Thanks very much.